is T, J Cuba here, and today I am going to be showing you how people researched that there's 42 quintillion or quintillion, quintillion ways to do positions on a Rubik's Cube. So yeah, let's get started. So I am going to zoom out whenever I need to. So let's just write it down. Now let's see how many corners there are. So on a 3x3 Rubik's Cube, you can count them: 1, 2, 3, 4, 5, 6, 7, 8. There are 8 corners. So actually I'm going to zoom out for now. So you're going to write 8 and you want to put an exclamation mark there. What does that mean? That means that, so let's say 8 would be 8 times 7 times 6, and it will carry on. It's because, why we do need that, because once one corner is in, we still have 7 positions. When that corner is in, I have 6 positions, and carry on. And you could do this up to 2, or you could do it up to 1, but it doesn't matter. Now we'll do the same with the edges now, because we've done that. So if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, there are 12. So we'll times it by 12 exclamation mark. That's because if it's 12 times 11 times 10 and so on and so on. Now we're not done here, because if you look, each position on a corner piece can be twisted like that. So that's an actual case you can solve. So if I do that, so each corner piece can be twisted. So that's 8 corner pieces. So let's write times. So we need 8 corner pieces. We need to do it by 3. So wait, we can be permuted in 3 ways, and we're just going to write a little 8 at the top. So if you can see there's 8 that represents the corner still. So yeah, then we need to times that by the number of edges. So you already know it's 12, but how many positions can that edge be in? The answer is 2. So an edge can be flipped. This is 1, and if it was flipped, it would be 2. So it will be times by 2. But we're not done yet, because if you know that you cannot solve a Rubik's Cube with like one corner twisted or one edge flipped. So I'm going to be showing you why. We're not showing you why. I'm going to be showing you what we need to divide this all by to get our answer. So what we need to do is we need to divide this by the number of permutations each one can be. So we know that you cannot solve it when an edge is flipped in 2 positions, so you cannot solve it in 2 positions, and it can go in 3, so we'll do 3 times by how many edges there are, so these are 2. Do 3 times 2, and we need to do another times, and this will determine, because you cannot just swap 2 pieces, it's impossible to solve. So if we swap these 2, it will still be impossible to solve. So you can only do 2, but if them 2 are the same, that means it can be. So 3 times 2 times another 2. So if we work that out, 3 times 2 equals 6, and then times 6 by another 2, which equals 12. So we need to divide this by 12, and then you get your answer. Now I'm going to be showing you what it says on a calculator. Hey, now you can see that I'm on a calculator. So let's write everything we've done now. Now I'm on a different calculator than the normal one because I don't think they have all of them. So let's just use it. So there's 8 corners, and we said this, we have to write that exclamation mark, which is, I believe it's called factorial, and you times it by same edges, so there's 12, and then also factorial. Now that's already a lot. Then we need to times it also by 3, and we're gonna mention the 8 again. So we need to write it above, so 8. We also need to times it by 2 because that's how many edges can be flipped. And then we need to mention we need to mention the 12 again. And we need to divide it by 12 because that's how many positions in there. And then if we click equals, that's our answer. It's 4.325E19. So that's how many positions. It's 43 quantillion. So let's just get back on the normal page, and I'm just going to show you again. So let me just get out my thing. Who's back onto that paper? As you can see, I did write it down. Now I'm just going to show you again. So it's 8 because that's how many corners there are, factorial because they all can be permuted, and you times it by 12 because that's how many edges there are, and then that because they all can be in different positions, like 8. We need to times that by 3 because the corners can be in positions, and 8 because they all can be in different positions, and times by 2 because all the edges can be flipped, and with a 12 on the top because they all can be permuted, and then you have to divide it by 12 because we can flip each corner piece like that in 3 positions, and these can be flipped in 2 positions. So 3 times 2, 6, and then you have to times that by another 2 because you can never just swap 2. So we need to times that by 2, which is 12. So we'll divide that by 12, and that will equal you 4.3252E19. I believe E means how many zeros there are. So yeah, that's being how many positions you can have on a 3x3, and out.